Welcome to qnawire.
In the problem, we are given the circuit and are asked to find V naught and I naught. We could simplify the circuit into its parallel connections as shown here, where the 70 ohms is in parallel with the 30 ohm resistor, then the 20 ohm resistor is in parallel with the 5 ohm resistor. With this, we could simplify the parallels connection and convert it into an effective resistor. Let's place it as Ra for the effective resistance of the 70 and 30 ohm resistor, and Rb as the effective resistance of the 20 and 5 ohm resistor, where Ra is equal to 1 over 70 plus 1 over 30 raised to negative 1, which is equal to 2100 over 100, or 21 ohms. Rb, on the other hand, is equal to 1 over 20 plus 1 over 5 raised to negative 1, or equal to 4 ohms. Now, this effective resistance is important so that we could get the total current passing through our voltage source. So let's place IT here for total current. We're using Ohm's law. We could find V equals IT times R effective. Our voltage source has an EMF of 50 volts, and the effective resistance is Ra and Rb in series connection. So we simply get the sum of that, which is 21 ohms plus 4 ohms. We get 50 volts equals IT times 25 ohms, or IT is equal to 2 amperes. Since 70 ohms and 30 ohms resistors are in parallel connection, we could say that the voltage of Ra is equal to the voltage of the 70 ohm resistor and also equal to the voltage of the 30 ohm resistor. If that is the case, we say that Va, or the effective resistor A, is equal to IT times Ra. Since we now have the current passing through the entire circuit, we could solve for Va, which is 2 amperes times the effective resistance A, or 21 ohms. Hence, Va is equal to 42 volts. We could place it here as plus minus 42 volts. For Vb, you can see that they have the same voltage as the 20 ohm resistor and the 5 ohm resistor. Doing the same method, we get Ohm's law as Vb equals IT times Rb, which is equal to 2 amperes times 4 ohms. We get Vb as 8 volts. So we write it down here as plus minus 8 volts. Now, we could say that V naught is just the voltage across the 5 ohm resistor. And we already have that value. and that is 8 volts. Hence, V naught is equal to 8 volts. Now to get I naught, we go back here in our initial circuit and we find that the current passing through the 70 ohm resistor gets split into I naught and the current passing through the 20 ohm resistor. So we could write the equation as I passing through 70, or the current passing through the 70 ohm resistor, is equal to I naught plus the current passing through the 20 ohm resistor. Rewriting the equation, we get I naught equals I70 minus I20. We could get the current passing through each resistor using Ohm's law. That is V equals IR, or I equals V over R. In the case of the 70 ohm resistor, that is equal to 42 volts over 70 ohms, minus for the current passing through the 20 ohm resistor, that is 8 volts over 20 ohms. We'll get a final answer for I naught as 0.2 amperes.